Actually, they talk about backward techniques, and they said, oh, this is nice, we built systems like the Wright brothers built airplanes. Build the whole thing, push it out to tech, let it crash and start over again. It sounds very familiar, right? You're actually still doing the same. There was a considerable amount of debate on what some members chose to call the software crisis. And now, so they introduced the term actually. So there's also now still a debate on software engineering. What is it? Okay, which one is the right answer? Since you are very known to process such questions, let's do it like that. So, ask you to. And see, it's not an engineering discipline, yes, you do. And see, cannot be an engineering discipline due to the different nature of software. J. And C is rapidly approaching towards becoming a mature engineering discipline. There, sure, SE is an engineering discipline. And none of the above. Okay. Who says A? Who says B? I adoro. C? Okay. D? Tem bits of C. And D? Alright. And E, none of the above. Çoğunun fikri yok. We will come to this, okay? Just remind this, okay? Let's look at the definition of engineering, which I took it from Mary Shaw. I like this definition. Creating cost-effective solutions to practical problems by applying scientific knowledge, building things in the service of mankind. That's engineering, and all of engineering is fit actually to this definition. They create cost-effective solutions. They are dealing with practical solutions. They apply lots of scientific knowledge. They build things, and in service of mankind, isn't it? So the question is software also engineering? Can we put it in the branch of software, of engineering? Let's make a hypothesis. Okay, we said it's solving life problems. We said let's say software engineering is engineering, and engineering is problem solving. Okay, is the truth. Well, engineering is problem solving, and the question is this true? So this is then our common ground for comparing these. So the question here is, how has engineering evolved throughout history? How do they solve problems? What are the lessons that we can derive from history of these mature, classical, traditional engineering with respect to problem solving? Okay. Well, I go very fast through this. If you look at the engineering disciplines, they all started with primitive problem solving. Okay, there's some need, and then they directly built the art. There was no, so I said it's craft-based, no activity of design, no application of scientific knowledge, and it's no mathematical modeling or whatever. It's basically controlled by tradition. Then the next phase of all these engineering disciplines is design-driven problem solving, I call it. They first describe the problem, and then you define the solution description in drafting, they call it, also in all the engineering disciplines, it's the design. And then they implement the artifact, which has, again, an impact on the needs of the society. The next level of problem solving in engineering, so it's the evolution of engineering, is when over time the scientific knowledge gradually evolved. Okay? Physics evolved, for example, then electrical engineering could be more mature. So physics and mathematics. So how does what's the model here? So we have again the problem description. Then we see that there is the search for solution domain knowledge, and solutions are derived from the domain knowledge. And after that, the design is given, and based on the design, an artifact is implemented. Okay. So that was the part. And if you look at current engineering disciplines, just go to the library or check Amazon sites. See, check the handbooks of these engineering disciplines. Mark Standard Handbook for Mechanical Engineers, 1,800 pages. Handbook for Civil Engineers, 1,600 pages. This one is even almost 4,000 pages. Paris Chemical Handbook, 2,640 pages. If you open these books, they contain lots of knowledge, mathematical knowledge, engineering knowledge, which is consolidated, proven by experts in the domain. Okay, it doesn't change a lot. I studied 1 year in electrical engineering, by the way. I found it boring. Software engineering is much more exciting because we are in the domain and following the domain. With all respect to my colleagues who do control. What we see here in the last phase is using of mathematical modeling in these engineering disciplines. So after the solid knowledge, what we see, mathematics evolved, and then they could just mathematically evaluate the alternatives and optimize the solutions. Okay. And let's look now at software engineering. Also from the history, 1940-45, we see problem solving in software engineering was primitive. Okay. A need, just implement. Currently we sometimes still see this kind of problem solving. But then we see, similar to the evolution in engineering, we see the evolution of design. We have structured design methods, case tools for drawing, object-oriented analysis design methods, design patterns, and since 1.5 decades, software architectures. Okay? It's the same kind of evolution. Then we saw evolution of domain. First it's mainly computer science, isolated part, but now the last decades we see also increasing size of pattern knowledge. But the observation is still quite meager with respect to traditional engineering. We don't have handbooks with 4,000 pages. Pressman, maybe I'll use your style, I don't know. And control driven is even worse. Optimizing solutions in software engineering, you don't see that often in practice. Okay? But we can still compare mature engineering, software engineering, and we can make some conclusions about this. But the bottom line here is that software engineering is just evolving in the same way as mature engineering, and also evolving in the same parts of mature engineering. So in the problem description, design descriptions, solution domain, and control. Okay, if this is the time, you see here is mature engineering, and where software engineering. Well, it's almost like it depends on the practice, but we are approaching the end. So you were right with it's engineering, but not mature yet. But it's past the repetitive engineering. That's the point. So no discussions, debates about this, whether software engineering is engineering or not, I found it quite useless, because it is becoming engineering, and even because it is already more important than the other engineering disciplines. Okay, this is the case, so it's very important. It's one of the engineering disciplines, and our knowledge on engineering has evolved. It has become even important in industry, even in organizations which have never considered software, which have never foreseen that they would use software. Now they depend on software. Without software, they will not be competitive. And if this is the case, so we have lots of knowledge. It's important in society. So there's an obvious need or graduate in software engineering. It's in Europe the same, in Asia it's the same, also the same, counts also for Turkey. Okay? And okay, you are here because you are conscious about this, but I think you should spread this message all together. But, okay, what kind of knowledge is available? What should be taught and how? This is a slide from Philips Semiconductors. We are doing projects for them. It's very interesting. So in 1978, it's about the TP software. 78, we had one person needed for implementing. Productivity was 1 kilobyte per person year, and this production. And in 2004, more than 100 people are working on software development. Required code size in 2006, 32 megabytes. Okay, who's going to design, create this? That's a real, relevant, important question which needs to be considered. So of course, they do some in-house development, which is got less, and also outsourcing and Bangalore, but it is a problem. Who is going to do the work? So we need software engineers. So what is software engineering? Often people are not confused. Okay, there are two views about the relation of software engineering and computer science. First of all, software engineering is not a discipline by itself, but is applied in different subdisciplines in computer science. So, software engineering, there's no place for it. Look at some of the curricula in the universities, those studies in the term, right? Yok, software engineering yok, sanki hiç önemsiz. It's the most important, actually, one of the most important disciplines. So you should focus on that. So this is a better vision. Software engineering is a subfield of computer science, but still not optimal. This is already nice. If you have this, it's okay. The other one is based on actually from Parnas. Yeah, if you look at other engineering disciplines, what they make actually separation between engineering and its scientific basis. Electrical engineering has physics, mathematics, application. This is engineering, this is the science. Typically, they have different science departments and different electrical engineering departments. Okay? Also, the graduates do different things. Same for chemical engineering and civil engineering. They all have some basic science. They all use mathematics, and they have also considered applications, which are so the artifacts, which are different per engineering discipline. So according to Parnas, this should be the same also in computer science. We should have some knowledge about software engineering, and this should be based on some basic computer science knowledge, mathematics, and application. There's a software engineering body of knowledge. It's published in 2004 by Iii.Uyms with the aim to collect and organize all this knowledge. So actually the sum of knowledge within the profession of software engineering. So we need to build this core knowledge. And they also defined a guide for this, to use the body of knowledge. So this is the, you can check it. What do we see here, for example? The knowledge area, software requirements, design, construction, testing, maintenance, etc. And there are related disciplines, like we said, computer science, mathematics, and so on. So what should engineers know, software engineers know? They should know the body of knowledge. Okay? They should know how to apply that knowledge. They should not extend that knowledge, well, in the very theoretical sense, to be able to apply that knowledge, but also the knowledge about in computer science. And how to apply this broader domain of knowledge to build products for application domains. Okay? This is the vision so far. This is a possible Master of Science Software Engineering program. Well, it's from Parnas. So you classify based on course shared with other engineering disciplines, introducing other engineering areas to software engineering. I will not list them. Some mathematics and software courses. You can check this and then decide, compare existing software engineering Master of Science curriculums. And first, taught üniversitenin program alayım. Şöyle bir geliştireyim. When I didn't do. And let's first look at our own program. I'm from the University of Twente. This is not perfect, not optimal. It's not my intention to say, but just to show also what we have. We have core courses. So core courses, advanced course, elective course, and graduation project. This MSc for computer science software engineers. 120 credits. So students should select 6 out of these core courses, including mathematics and so on. Then we have advanced courses which are just focusing on software engineering domain, and elective courses. This is not optimal, and as I know, there are also lots of compromise, but at least we should aim to form a good software engineering program. Okay? What kind of courses can be given? For example, well, there are lots of courses. Okay. Very often you see 1 or 2 courses. Object-oriented software engineering is seen a lot, but then people don't go further. Software architecture design, model development. So it also means follow the developments. So internship, we do it in the Netherlands 3 months. Here it's basically 1 month. I think 3 months is much better because you can really do some work. And PhD, I said all Europe. To me it sounds, I've seen some students PhD have to do some 8 courses which are not related to their topic. In the Netherlands, we have they start, they do directly research. Okay. You give them papers, they read the papers. Okay. No other things. Okay. We wouldn't even allow to follow the course which are not relevant. They want to follow the course to gain some knowledge, it's okay, but it's just 4 years of research. That's much more effective than just having 8 courses. You let them follow, and then till the time in the last 2 or 2 years, can finish PhD. Well, if you do it well, it has an impact on education has an impact on industry. So if this works well, you will get highly qualified software engineers, which will be provided to industry. If industry works well, society goes well. Right? So we all do well. Okay. Well, what to do in Turkey? Okay. Who am I? But still, we had a 15 minutes. Make a plan for common 5-10 years. I was a lot more quality software engineering courses should be introduced. In BSc and MSc courses, PhD research in software engineering topics should be supported. For real Master of Science software engineering programs, even with multiple universities, or exchange programs with other universities abroad. Software should not be seen as an asset to gain some resources, no, to be a service for mankind, you say, right? So what's the relevance of the industry? Aim for hiring the coming years. Well, this is a sharp statement. Basically, academic person with a clear software engineering background. Well, if there's a problem, we should focus on that problem, right? And we could also think of other things, issues, but at least we should be starting to think about it, right? And I heard also in some of the discussions before, complaining either about government or institution or that, but it's a responsibility of all the stakeholders in the game. That's education. Research. We can do very nice education, okay, but still it could fail to impact the industry. So even in a mature software engineering, and even if you have very nice programs, our research might fail. In which case, well, if we treat research and involvement of the industry and applying the research as separate activities. So like research is just a concern of academy, and then so you see it fully separate. So what should be research? How to set this up? So on the one hand, we could just nurture the tree or software engineering, put the programs, but if we could also burn on the other side, so the research. I came from Manchester on Wednesday. I was in the project. I was in the airplane, Turkish Airlines. They had some on the monitors you get commercials. There was an exhibition of Horof Zihni Sinir from İrfan Sayar in Istanbul, and they just showed some nice cartoons. I really liked it. So, some inventions which are very intellectual actually, but they are actually nonsense, right? This is like mesela motosikletin dönüşen otomobil. Bir köprüde geçeceksin, ben motor yapıyoruz, and you pay less. It's quite funny. Amara bisikleti, while she is biking, she makes also, dikiş yapıyorsun. Ayıkla pirincin taşını makinesi. Very intellectual process, but very okay. And then the aya geçitleri. If the car doesn't stop, maybe this is useful in Turkey, but so what's the analogy here? So we could do research and have very intellectual, nice papers and so on, but if it doesn't fit the industry, the society, it's useless. Yeah. Okay. So we should also focus on research. First level of that is, of course, no research. We have lots of problems in industry. We are waiting for some support from the academy. Okay, they're doing some projects. And on the other hand, there's no research on that. Okay, this is one. This is bad. We should skip this. In many cases like this, unfortunately. Second is, we could do research. Okay, have problems and you do research, and they are all completely separated. There's research but no transfer. So, herkes kendi yoluna gidiyor. There's no connection for them. Where's the connection? Why do you do research, right? Why do we do engineering, science? Third one is research, then transfer. This is a big step. So there we have some problem from industry, and then the researchers here, they get through anecdotal knowledge, some inspiration, and then they define some problem for research. But after that, the problem in the evolution evolves, and the research just also evolves in its own way. Okay, there are different tracks, and in the end they want to do technology transfer, but it will be very, very hard because there's no interaction in between. The problem evolves invisibly here to this community. There's no evaluation in between. This is research, then transfer. What are the problems here? weak connections even from the start, lack of interaction to define the problem. Okay. What kind of KVF in the beginning, but not later. So this causes both research and practice to evolve separately. There is a delay in evaluation. We wait just till the end. And actually, evaluation is very difficult, evaluation and transfer. We could actually say there are no real winners. We could say, as researcher, I'm consider myself a software engineering researcher, not a practitioner. We could have lots of papers, and we could say I'm a winner. But if it doesn't impact the industry, the society, I'm not a winner. So the more mature approach of research is industry as laboratory. It has been introduced by Potts, Colin Potts. What's the process there? Here we have the problem and research solution continuously interact with each other. Okay? We have here a problem, and then there's lots of interaction. The problems are derived from the industry. Research problems are defined and then evaluated again in the industry. And there's continuous interaction. Okay? Let's focus on one of the cycle. Okay? Here we have application domain problems, the industry. We have real case application and pilot projects in academia. They provide field case problems here to evaluate. We are not interested in developing concrete products, but we evaluate the real problems, we abstract from it, we define the research topics, and then do research. Okay. Then we apply research solutions to real case, perhaps some evaluation. We get direct feedback from industry. Is it really relevant? Does it really have an impact? It's not about building products. I will show you an example of my own experience. And then this cycle goes on. Then we have to be finished, and then we do technology transfer. We can do technology transfer. We are winners. What is the advantage here? Problem is acquired from the real practitioners. They are real hard problems. Constant interaction by practitioners and researchers, which enables early evaluation of our ideas and optimal reduction of technology transfer gap. This becomes much more easier. So, industry as laboratory emphasis the real case studies. Let's get this one. You could say, what about publications, academician? Well, since industry as laboratory focus on real case studies, we have real hard problems, and we can evaluation of research can be done in industrial settings, so you get more reliable results. These are actually all ingredients for high quality publications. Right? Year one, this is very valuable for us. If I can have some real case from the industry showing some concrete problems which I can abstract to my research problem, it's great. Yeah, I can define research topics, and once we have done the research, we can apply it in a real industrial setting. We can evaluate, experiment, and we can publish. There are some concerns here, of course. You might object and then say there could be overemphasis on the short term. Should be careful. You should not delve too much into detail. Yo-yoing between details and abstractions, you get concrete case. You should be able to abstract from it. Discomfort with lack of control. And since you are interacting with the industry, you are not fully in control. You are also dependent on project constraints. And there could be a tendency that technology transfer is easy, but it's also not like that. Even if you have a very good solution in the end, technology transfer is a process by itself. and loss of privacy for industry. They are very reluctant to get all their details. So there should be some confidentiality. Must be preserved. So what's the idea?